Greetings, Earthlings. Today we're going to talk about a BCS Sickle bar. This is kind of a setup video, so I'm going to walk through the setup procedure when you get the sickle bar from us, what you're going to be doing to prep it and get it ready for work in the field. This particular one is a double action sickle bar. I'm going to cover everything we need for the double action, which pretty much applies to everything for the single action as well. We also have videos on the complete maintenance of both single action and double action videos. That's two separate videos. And you can watch those. They're like 30-40 minute long videos with chapters in them showing you how to do the various functions. But this is going to be a quicker video, just kind of getting you started with a new sickle bar, and we're just going to do one. I'm not going to do one for single and double action because we can cover everything on this. So, first off, if you've received this thing from Earth Tools, if you've had it shipped by motor freight, it's going to be assembled the way you see here. The gearbox assembly or drive assembly for the sickle bar will be mounted to the blade. This one happens to be a BCS 71-inch double action sickle bar with the guarded fingers. The hood or the plastic shroud we will usually ship in its own box. If we mount this before shipping, the motor freight people with their forklifts have a great tendency to just destroy this thing. They'll just hit it with forklifts and everything else. So much rather put it in a padded box and let you put it on there. When you're putting this on the double action bars, this lower bolt that holds it in place will typically be in this location where it needs to be. Now, if you've had this thing shipped to you by parcel carrier, like by UPS or something, this gear head will not be mounted. The blade assembly will be in a box and the gear head will be in another box with the shroud. In that case, this fastener will be in the kit bag that comes with the thing with all the other fasteners. But when we're shipping in motor freight, we kind of pre-assemble some of this stuff. Like this bracket that holds up the rear end of this, we kind of stick it on there with the fasteners it needs. If you've received it by UPS, all this will be disassembled in the kit bag and you need to put it together. So the important things here are that on a double action bar, this bolt is threaded into this arm. On a single action bar, there's no threads here. The arm, it just has a hole through it, and there's a nut that goes on the bottom. So that's a little difference there. The hoods are basically the same. There are two styles of bolts. This bolt, the one that goes on the lower end, is always going to have a slight chamfer to the bottom of the head. That's because as this arm moves back and forth, this whole hood moves back and forth too. It kind of shakes the grass down off of it. It's a very important part of the sickle bar. Without it, you just can't hardly run the thing. But as it kind of wiggles and oscillates back and forth, you don't want the edges of that bolt eating into the plastic surrounding this rubber bushing here. The rubber bushing's top and bottom. So the top bolt is just a standard bolt. It's got its regular flat head on the bottom. This bolt with the taper on the underside will be a longer bolt on the single action since it has to pass all the way through and have a nut on the bottom. Also, the top bolt, which I have not tightened here, this is a little different assembly process in that, whoops, I dropped a washer. They give you two washers for it. One washer is going to go under the nut, or above the nut rather. Usually I put the nut on the bottom. And the other washer actually goes between the bracket and the bottom of this thing. So basically the assembly procedure is bolt with no washer, washer, bracket. Actually, I've got that back. Bracket will be like this. And then another washer. Whoops, I can't do this. It's actually a lot easier if you have this thing mounted already and then you put the hood on top of it. But you can see what I'm doing here. This washer and then your nut. And that gets fully tightened. Both fasteners get fully tightened. Some people think, oh, I need to leave that a little loose so it can pivot. No, the rubber bushings allow it to pivot. The bolts and nuts need to be tight or else you will lose them. So that's the assembly process there. This little rubber plug in there, people wonder what that is. That's a holdover from an earlier time period when they used to have a greasable bearing down in here. They no longer have that on any of the BCS Cutter bars. That's kind of an old-fashioned thing, so that really doesn't do anything. aside for now. When you do put this bracket on, you'll notice there is only one fastener supplied with it, a nut and bolt and washer. And you're like, well, how is that going to stay upright with just one fastener? And that's a good question, because it wouldn't normally. Well, let me get this thing off of here. Come on, bolt and nut, cooperate. There we go. That's a lock nut, so kind of bring it down on there. Tight enough to stay. So the deal is, there are two holes through this casting, but the lower one has a roll pin driven through it. It's like a spring pin that's been driven through there, and it protrudes a little bit on the other side. You can see it stick out there. Well, the lower hole on this goes over that spring pin, and that gives the thing the location it needs, like so. Put their bolt through, they give you two washers, so you put one on each side. And then when you crank that down, it kind of wedges it into that spring pin and gives it the vertical stabilization. If you only had one fastener, the thing would just flop back and forth. So I don't exactly know why they do it that way. They could put two nuts and bolts through there, but they always use the spring pin on the lower one. Whatever, guys. It works fine. There is some height adjustment built into this. There's like two positions you can mount the upper half of the bracket to the lower half. Doesn't make a whole lot of difference. But if you have taller wheels on your tractor, you might put it in the higher position. As I say, it doesn't seem to make a whole lot of difference. The gearboxes here, the drive units, have oil in them, 90 weight gear oil or 80W90 gear oil. There's a check plug on top. We've typically checked it here, so you don't have to worry about it. But if you want to do your yearly maintenance, from year to year, at the beginning of each year, you take that check plug out, stick a wire or a screwdriver or something down in there, and roughly you want about a third full. So this thing is about 4 inches tall, so if it's got an inch and a half of oil in it, that's fine. The lower half of the gearbox is much bigger than the top half of the gearbox, so even if it's only got an inch in it, it's still half full by volume, so that's fine. There are a few grease fittings on these things. There's always going to be a grease fitting on the tail end of the gear housing here. That grease fitting, it's just a regular Zerk style grease gun that fits on there. That grease fitting lubricates this right here. This is the swivel assembly that allows the sickle bar to float to follow the ground contours, because this, of course, this coupling is going to be bolted to your tractor, so that's solid with the tractor. So this thing, like I say, it allows the sickle bar to float, so you can get a good cut even on uneven surfaces. So you just lube that once a year. You basically grease this until you see grease oozing out around here. It'll start squirting out the little seam there. We'll have greased that when you get this, so you don't need to do that right off the bat. The other grease fittings on a double action sickle bar, these are not present on the single action. You've got two grease fittings here on the drive bearings that drive the sickle bar blades back and forth. There are two of them on a double action because the double action has an upper and lower blade that actually move, unlike the single action where the lower blades are stationary and just the upper blades move. So these are greasing some little needle bearings in here. You just put a grease gun on it, and maybe 2 pumps is all it takes until you see grease oozing out from under here in both places. And during normal use, you're going to grease those probably every 10 hours of operation, something like that. I'm not a really big fan of that needle bearing system. To me, the needle bearings don't last as long as the old style drive system. Actually, the single action bars still use the old style drive system, which is just a metal bushing with a metal pin in it, and you spray some lube down in it, like spray grease or something like that. And the nice thing about those is it's just a solid piece of metal against a solid piece of metal. And the vibration goes back and forth. I mean, this thing is going back and forth 700 times a minute. And the solid against solid just seems a lot more durable in our experience. And they'll last many, many years before they have to be replaced. These ones with the needle bearings in them, which is some cockamamie idea BCS came up with a few years ago, they last okay if you keep them greased, but the thing is there's not as much surface area actually contacting on a needle bearing because you're just on the points of the needles. So once they fail, finally, we still stock the old style ones, and you can just convert them back to the old styles, which are cheaper and more durable. And they don't have grease fittings you need to worry about, so it's better all around. The blades are all pre-adjusted and ready to go. One thing you're going to notice is there is a complete extra upper blade assembly packaged with all BCS brand sickle bars. So this is the top blade assembly. That's the one that usually takes most of the abuse because the lower blades are heavier and thicker than the upper blades. So you get it, they give you a spare. This is worth like 150 bucks or more. That's great. That way when you chip up and bang up one blade by hitting a bunch of rocks, you can just swap out the blade real quick and go back to work and then fix up the damaged blade when you have time. We have all the blade switch out procedures and all those repair procedures on our repairing and maintenance video. And then we have a video for sharpening the sickle bar as well. That's a separate video. In the parts kit, there will be some extra teeth and rivets. So individual sickle bar teeth, maybe 2 or 3 of those, some extra rivets. There might be some other extra hardware. In the double action kit particularly, they give you like an extra spring arm, an extra lower tooth. Since those are mobile, there's a little more chance you might damage it. And on the double action one, they also give you a tool to remove the spring arms from the top of the blades. Basically, it kind of pries these up and swings them off to the side. That's demonstrated on our maintenance video, so I'm not going to go through that right now. But all that stuff is in your kit bag. Don't lose the kit bag when you get your sickle bar because there's a lot of important stuff in there you're going to need eventually. The skids will come, if you're buying this assembled by truck freight, like this one is going to ship, or if you're picking it up here from Earth Tools, the skids will be assembled to the sickle bar. If you're getting this by parcel carrier, all disassembled, you'll have to put the skids on. So these skids, I want to talk about these a minute because BCS has gone through a lot of iterations on skids over the years, and this is their latest, which are pretty good, better than some. Probably one of their best, really, but it's got a couple holes in the plot, which I want to go over. One of the things is they built these skid support brackets to actually mount to the top of the sickle bar. And if you look at the pictures that are supplied in the owner's manual and so forth, they're going to show this bracket on top. Well, these are the adjustment bolts that adjust the height of the sickle bar. Basically, what happens is you've got these sort of radiused, sort of curved piece of steel here, and then a clamping mechanism on the bottom, or this clamping piece that comes up and kind of pinches it in place. The holes that these bolts pass through in the skid body are actually long slots that are kind of curved over like this. So once you loosen up these bolts, you can just rotate this skid a certain amount. It rotates about 20, 25 degrees to whatever position you want, and you just tighten it down. Great. The problem with that is that, number one, with the skid bracket mounted on top, the maximum inclination of these skids doesn't get you very high off the ground, maybe 2.5 inches, depending on your tractor tire height, which of course affects the angle of the sickle bar and how effective the skids are. And a lot of people in this country, in North America, want to mow a little higher than that. They've got rocky ground or uneven ground and they don't want to get into the ground. They just want to get it up a little more. So the way these brackets are formed, they're a cast bracket, they kind of have a raised part right here in the middle. And we couldn't just put it straight on the bottom because then where the bolt went through wouldn't be tightening down on anything. So we cut little spacers. Then what I'm touching right here is a little steel spacer that we cut. We've got one on each side and one on the, 2 on the other skid as well. And that allows it to tighten down on the metal of the spacers and not like bend the skid body when we put it on the bottom like this. But moving it to the bottom and adding the spacers gives you a little over an extra inch of cutting height. So you can get up to a good 3.5 inches with the standard skids without having to do anything fancy. We also have developed a riser kit for the sickle bar skids that pushes them down even further. You can get it up to 7 inches off the ground. That's an extra accessory available from us. So that's one thing that you'll notice is that it's like, oh, these look different than what's in the manual. It's because this is the Earth Tools version. We put those on the bottom. Now, if for some reason you decide, hey, I really want to cut low to the ground, which in Europe they often do because they're cutting a lot of alpine grasses up in the Alps. And they really cut those things low. I mean, alpine grasses may not get a foot high, so they cut them like an inch high. So they'll actually run without the skids sometimes. So if you need to cut low, the point is you can move these back to the top. You just have to use a little shorter bolt because obviously we've added an extra long bolt to pass through those bushings. So they can be remounted to the top. It's fine. I think typically, well, there might be some extra bolts in the hardware kit that would allow you to do that. If not, you can pick them up at a hardware store. It's no big deal. 5/16 fasteners will go through there just fine. What's in it now is metric, but 5/16 is the same diameter. And that actually brings us to my next point, which is these bolts, the adjustment bolts. The ones supplied by BCS are 8mm diameter metric bolts. They are not hard enough. We have found, especially with heavier bars like the 71-inch bar, you just can't get those things tight enough to hold the skids in position if you're on rough ground and they're having to bounce around a lot. I mean, if you get them tight enough to where they'll stay, you just strip off the fasteners. They're not hardened. They're like a grade, they're an 8.8 metric, which is roughly equivalent to a grade 5 standard bolt. And you just, by the time you get them to the torque that they would actually hold, you strip them off and they just won't hold. So we upgrade these things to 5/16 hardened grade 8. They're SAE grade 8, which is equivalent to like a metric 12.9 bolt. It's the same diameter as the metric 8mm, 5/16 and 8mm are identical. So we pass that through there, we put hardened nuts on the bottom, again, 5/16, and we actually use fine thread. The ones that are supplied from the factory are just coarse thread. But these nuts, the nuts are changeable because the nut is just an insert into this curved piece I pointed out here. So the nut just inserts up in there, it's got like a hex shape. And the outer diameter of the fasteners is the same between the metric and the standard. So again, what we supply here is standard grade 8, 5/16 fine thread. That would be a 5/16 24, and those you can get enough torque on to actually hold in position. So if you bought your Sickle bar somewhere else and you're wondering why those things don't work, go to your hardware store and get some of these bolts and it'll solve your problems. There are also adjustments that will be done over time, like taking the slop out of your blade couplings as they wear. That's all covered on our maintenance video. One quick thing I want to talk about here in terms of just general maintenance is that when you're done using the Sickle bar for the day, that is the most important time to lubricate the bar itself. You don't really need to lube the bar while you're mowing out there. It's just metal on metal, but typically the moisture from whatever you're cutting, the grass, weeds, whatever, provides ample lubrication to keep all the parts moving. But once you're done, the thing is you've got moisture on the blades from what you've been cutting, and now it's going to sit in the barn. So that's when the rust happens, because you've got moisture on bare steel and it's going to rust. So that's the most important time to get some lube on it. The old farmer method of doing this was and this goes back to the old mowing machines on tractors and horse-drawn equipment and stuff like that, is you kept a jug of drain oil, a bucket of drain oil in the barn with an old paintbrush in it. And when you pulled your Sickle bar into the barn, you just pulled the paintbrush out and went down the length of the Sickle bar, and then put the Sickle in gear for a couple seconds and let it work the teeth back and forth, and it would work that oil between the moving parts of the Sickle bar, and bang, you're done. The oil will displace the moisture that's on the Sickle bar and lube those things, kind of pre-lube them for when you go out to the field the next time, and it keeps the rust from happening. Because every time the Sickle bar rusts and then sits there and you start it up and go out and run it some and work the rust off of it, every time you do that, it rusts, and then you work the rust off, you've just lost some steel, which means you've taken some of the edge off your Sickle teeth and you've shortened the life of the teeth. So you can keep it from rusting in the first place, you're much better off. It holds the edge a lot better. And you don't have to use drain oil. You can use any kind of oil you want. There's like lanolin-based lubricant like fluid film that you can spray a spray bottle, aerosol can, or a squirt bottle. I wouldn't use something like penetrating oil. WD-40 or something like that is going to evaporate in a few days and not going to give you long-lasting protection. So you want to use something with a little more body. You could even use vegetable oil, although if you put vegetable oil on it and it sits there for a long time, like over the winter, that vegetable oil can actually turn into kind of a cement and just glue the thing together. So you would only want to use the vegetable oil for short periods of storage. So that's it. And the most important thing I will interject, we have this all over our website, but I'll say it one more time. When you're running a Sickle bar, whether it's a single action or a double action on a walk-behind tractor, never exceed 1/2 engine throttle. Engine throttle is directly proportional to your PTO speed on a walk-behind tractor, so the faster you run the throttle, the faster the Sickle bar reciprocates. And when you exceed about half throttle, the reciprocation speed on these things will be so great, you will damage these blade couplings like crazy. You will possibly break bars in half, like the moving bar. All kinds of problems happen when you get over half throttle. Even the double action bars, which are a lower vibration bar because you've got the upper and lower moving simultaneously, still should not be run over half throttle because it's not about vibration as much as it is just metal fatigue on the parts. You don't need to go that fast. PTO speed on these things is high enough that you can run your engine slow. Sickle bars don't take a lot of power. They take a very minimal amount of power because it's just a big scissors clipping the material off. So I run a sickle bar between maybe 1/4 and 1/3 throttle. I never have anything break on the drive assembly. So word to the wise, if you want to go fast, fine, put the tractor in a higher gear. Don't run your engine faster. That's it. Thanks for watching.